So I'm Rafa Gómez-Bombarelli. I'm an associate professor in material science and engineering, and my group works at the interface of machine learning and simulations for materials design. My group works in a number of materials classes. We are purely computational. We don't do physical experiments, but we do collaborate obviously with people that do. So we're pretty agnostic about the materials classes and the applications that we pursue. For instance, we're particularly excited about a class of heterogeneous catalysts. They're called zeolites. They're these nanoporous materials. They have a regular porous structure that can accommodate different substrates. They're used today in cracking, in industrial cracking of oil, and they're also used for cleaning exhaust emissions from diesel engines industrially at the billion-dollar scale. And they're a nice combinatorial problem that is very tractable for machine learning. There is many possible materials one could make with many different compositions, and each of these will result in different potential applications. So we're utilizing our tools to connect the synthesis recipe to the material that emerges to the properties that it would have and optimize them all at the same time to achieve new catalysts for diverse applications. So a zeolite is a nanoporous ceramic material. So it's made of the same fundamental composition as sand or glass. It's mostly silica, but it can contain other elements that fine-tune its properties for either extracting, sieving molecules, or for catalysis by creating customized catalytic sites that carry out a reaction. Some of the future potential applications of zeolites for energy and sustainability would be, for instance, in biomass conversion, to take biomass products after agricultural applications and upgrade them to useful chemicals. That's a possibility. Another would be in CO2 upcycling. Zeolites are very selective catalysts, and they may be made in a way that allows for very selective transformations of CO2, and that would allow valorizing the CO2 that gets captured from combustion engines or from other combustion sources and put into valuable chemicals such as aviation fuel. Another possible application is for separation of metals. In particular, there is a lot of appetite for extracting lithium out of possible sources, and because of their selective nature, zeolites can be applied to extract these high-value metals from solution. The oil and gas industry already utilizes zeolite at scale for cracking. As the chemical industry needs to get decarbonized, both the suppliers of raw feedstocks out of refineries and the end users that upgrade them to more value chemical can benefit from more selective and cheap catalysts. As we decarbonize the production of energy and chemicals, the whole palette of catalysts that the industry needs to apply will need to change, and that can be optimized and accelerated through machine learning.